So let's see what this procedure looks like. We want to find the third approximation, x3, to the x-intercept of the equation f of x equals cos x minus x, and we're going to start from x1 equals 1. So the first thing we need to do is we need to find the formula we're going to use to get x2 from x1 and x3 from x2. To do that, we first need to take the derivative. F prime of x is going to be negative sine x minus 1. So this means that our formula is going to be xn plus 1 is going to equal xn minus, right, f of xn over f prime of xn, which means it's going to be xn minus f of xn is going to be cos xn minus xn. F prime of xn is going to be negative sine xn minus 1. So this is the formula we're going to be using each time to find the next approximation from the previous approximation. So we're going to do it with x2. x2 is going to be x1 minus cosine x1 minus x1 over negative sine x1 minus 1. So let's plug our x1, which is 1, into this formula and see what we get. We get 1 minus cos 1 minus 1 over negative sine 1 minus 1. This gives you a number that's approximately 0.75036. It's got more decimal places. I'm going to cut them off just to save space on the page. Okay, we've got our x2. It's going to be a sort of better approximation to the x-intercept of this function. So now we want to find x3. x3 is going to be x2 minus cos x2 minus x2 over negative sine x2 minus 1. And basically we're going to put in the 0.75036 in here. Minus cos 0.75036 minus 1 over negative sine 0.75036 minus 1. And what does this give us? This gives us approximately 0.73911. So the third approximation, x3, is this number, 0.73911. It's a fairly good approximation to the x-intercept of this function. This method, Newton's method, can be used not only to find x-intercepts of functions, but also to find roots, solutions of equations. Basically, if we want to find the approximation to the root of the equation, x cubed plus x equals 1, we just mentioned that the root of this equation, the solution of this equation, is the same as the x-intercept of the function f of x equals x cubed plus x minus 1. Basically, those are the same things, so we're going to use Newton's method. We're going to find the x-intercept of this, and that'll also be the solution to this equation. Okay, so let's take our derivative. F prime of x is going to be 3x squared plus 1. So my formula is going to be xn plus 1 equals xn minus f of xn, which is xn cubed, plus xn minus 1 over f prime of xn, which is 3xn squared plus 1. Great. So we can use our x1 to find our x2. x2 is going to be x1 minus x1 cubed plus x1 minus 1 over 3x1 squared plus 1, plugging in 0.5 for x1. What we're going to get is 0.71429 as our approximation. Then if we want to find x3, we're going to take x2 minus x2 cubed plus x2 minus 1 over 3 times x2 squared plus 1. So we're basically going to take the 0.71429, plug it in here, and we're going to get a number which is approximately 0.68318. So this is our x3. It's the third approximation to the solution to that equation.